All right, so in 11.4, we're going to talk about some basic probability things. To save some time, I've written some of this out and I'll kind of go through it and maybe add a few things. But there's lots of definitions and terms that we've got to be familiar with in 11.4. So obviously the first definition is the probability. So the probability of an event or a thing happening is a number measures the likelihood of that certain thing or event happening. Okay, and this number we have to decide what kind of number it is, and the probability can be a number that goes from 0 to 1, or probably more familiar is like 0% to 100% inclusive. Inclusive means that it includes the numbers 0 and 1, or 0% to 100%. Obviously, if you tell someone you're absolutely going to join them for something, you'll say, I'm 100% going, meaning you are definitely going. And the closer the number is to 100% or 1, it's more likely to happen. Now, when we talk about or find the probability of an event can be written as a decimal, a fraction, or a percent. And in my math lab, you will be asked for one of those, mostly fractions I found, but they may ask you for a percent or just the decimal. So you have to pay attention to what they want. Now, if they ask you for a fraction, they're going to ask you for a reduced fraction. So what I've done is I've taken 6/8. Obviously, we can reduce 6/8 to 3/4. So if we're working on homework, if the answer is asked as a fraction, this is the answer they're going to want. And they will call this a simplified fraction. That is what they mean by simplified fraction, means reduce it. Okay, that's one option. Another option is as a decimal. Both of these are acceptable, 0.75 or just 0.75. So write that. And then finally, a percent. So we can convert a decimal to a percent by moving the number to the right. To the right. So this is the percent. And if I wanted to go from the percent back, I would say 75 divided by 100, or just move the decimal just here. So percent means per 100. Okay. So now we have to talk about some definitions, really terms. I mean, these are things we're going to be saying, so we got to be familiar with what it means. So to do this, as I go through these terms, I think I want to use the example of a fair 6-sided die. So that's one dice has 6 sides, and it's fair, meaning each outcome is equally likely. Okay, so the set of all possible outcomes for rolling a dice is obviously 1, 2, 3, 4, 5, 6. Okay, but in general, that is what we mean by sample space. All the possibilities of doing that thing, that experiment. If I roll a dice, I could get 1, 2, 3, 4, 5, 6. If I choose a card from a deck of 52, I could get ace of clubs, the 2 of spades, the 7 of hearts. Each of those is equally likely. So for a 6-sided dice, our sample space would be written as 1, 2, 3, 4, 5, 6. Okay. And now this notation, these brackets that I wrote terribly, this is called set notation. This means that each of these things is an element of this set. That's all that means. Okay. So an event is the thing that we're wanting to observe or measure the probability of. So if I wanted to know the probability of rolling a 3, well, then there is one of those 3, so there's one way to do that. If I wanted to know the probability of rolling an even number, well, each of these is the event, because the event is rolling an even number, the success is each of those things. So there's 3 even numbers. Okay. And then I suppose I should give you the formula for probability. So what we're actually talking about in this section right now is theoretical probability, which I'll tell you that in a second. I'll write it down. But the probability of an event E, we got to call it something, is given as capital P of whatever, we'll call it E. If I wanted to know the probability of rolling a 1, I might put P of 1. Or pulling a 7 of spades, I might say 7 of spades. But that notation means the probability of the event. By definition, that is the number of successes, the number of ways to do that event. If I wanted to roll an even number, there's 1, 2, 3 of those, so the number of successes would be 3. The total things in our sample space is 6. Okay, so the number on bottom is the number of possible outcomes. Possible outcomes. So we could write that. We could also write it this way: the number of successes over the number of things in our sample space. That's another way you might see it. And this, where each thing has the equal likelihood, this is theoretical probability. So I'm telling you this is theoretical probability. You're like, well, what else is there? So we're not going to go into too much detail right now over the other type, but I need to tell you about both. So there are 2 types of probability. And then once I've mentioned these, we'll stop this video, and then the next video will take care of some homework. So the 2 types are obviously theoretical probability. What I just told you, theoretical. What that means is this is probability based on theory. If I have a 6-sided fair die, then there should be an equal number of each of those possibilities, 1, 2, 3, 4, 5, 6, should be equally likely. Okay. Probability of choosing a card at random, 1 out of 52. The other type of probability is empirical. And this is the probability based on collected or observed data from an experiment. When I see the word experiment, I think about like science labs or chemistry lab, but really this could be data from an experiment, a survey, a clinical trial, things like this, where they, have typically a large number of participants, people or things, and they're kind of observing certain qualities of those. So that's empirical.